Now, acids are solutions that are kind of molecular-like and ionic. Ionic in that they dissociate to form ions in solution. Molecular-like because they look like they have molecular formulas, but they all have in them hydrogen, which then ionizes in solution, dissociates, breaks down into ions, and the H positive causes the acidity of a solution. Okay, now that's a definition of an acid, but not necessarily a property. So what's the property of an acid? Well, they're electrolytes. They conduct an electrical current. Their pH is less than 7. So if you've got a solution that's got a pH less than 7, you have yourself an acid, and it has to be an electrolyte. They turn blue litmus paper red. Blue litmus paper in acid turns red. Blue, acid, red. B-A-R. When you go to the bar, you drink acid. I don't know, it's just a way to remember it, I guess. So the thing, well actually, if you went to the bar to have Coke, you dip a piece of litmus paper into that fizzy substance, that's carbonic acid in there that caused the fizz. Okay, that's carbon dioxide dissolved in water, carbonic acid. So litmus paper in a Coke would turn from blue to red. Okay, now acids also react with active metals to form hydrogen gas. You know in that redox chart, that half reaction that has hydrogen ion and H positive, it's across from 0.00 volts. It's the standard by which all the others are compared. That hydrogen half reaction in this position here, reacting with any metal that is a reducing agent that is below this hydrogen ion, will react spontaneously with that hydrogen ion, and the metal will break down, and the hydrogen will turn into hydrogen gas. So that's a property of acids as well. They taste sour. So when you take a piece of lemon, which has citric acid in it, okay, that's sour, all right? And if your autonomic nervous system works pretty well, you're probably just salivating right now thinking about biting into a lemon. Woo! So when you do that, you'll find a very sour taste. Anything that tastes sour, it's because it produces an acid inside your mouth. Absolutely. Okay, so acids taste sour. Now, here are some examples of acids. There's nitric acid, hydroiodic acid, hydrochloric acid, sulfuric acid. That's perchloric acid and hydrobromic acid. 6, 1, 2, 3, 4, 5, 6. Strong acids. Strong acids are strong electrolytes. That's why they're called strong. They'll break down in solution 100% and really light up a light bulb. They're highly conductive. But there are weak acids too. For instance, acetic acid, which is vinegar. I ain't going to drink any of that for you. That acetic acid will actually conduct an electrical current, but quite poorly. So we say it's weak in terms of its conductivity, so we call it a weak acid. Okay, those are the properties of acids. Bases are solutions that are electrolytes as well, but the pH is greater than 7. So red litmus paper turns blue when you put it into a base. Red litmus paper, base, blue. RBB, Rhythm and Blues Band. Because in a rhythm and blues band, one of the instruments you play is a bass. Okay, I tried. Now, they feel slippery to the touch. That's what a base does. So like soap actually has hydroxide in it, and it feels like a base. You know, lye, L-Y-E, that's soap, and that's made from sodium hydroxide. Okay, so they also taste bitter. So if you take a little bit of baking soda, and then you have a... Okay, see, that's a base face there, all right? There's acid, you saw that before, and base is So those are facial definitions, if you will, of acids and bases, or at least properties. Now, examples of bases could be things like sodium hydroxide, potassium hydroxide. No, there's sodium carbonate and sodium bicarbonate. That was the baking soda I just tasted. And then there's potassium sulfate. Okay, and here are some ones that might be tricky in terms of how they look, but don't get them confused with each other. Check this out. So look at these formulas. CH3OH, Li2CO3, C6H5COOH. And I say to you, which one's a base? Now, some students have learned that, well, when I see that OH, I'm thinking base. You got to be so careful. CH3OH is actually methanol, and we showed that before under the molecular compounds. That's not a base. That pH of 7 is what that would have in solution. And that, just because it has an OH, doesn't mean that it's a base. That's an organic type of hydroxyl group that's attached to CH3. So when you see organic, which is carbon and hydrogen, or hydrocarbon with an OH tacked at the end, that's an alcohol. Don't treat it as a base. It's not. Li2CO3 is actually a base because carbonate ion is a base, and you'll see that later. And so not everything that has OH in it is going to be a base, and sometimes things that don't have OH in it are bases, but I'll show you why in a second. They are. Now, see this one, C6H5COOH, it's called benzoic acid, because when you see this hydrocarbon formula, but then you see COOH, if you see COOH, you got yourself an organic acid. So COOH will tell you acid. Hydroxyl group on a hydrocarbon, though, that's molecular, and that is actually a base. That's coming up.